Hello friends, welcome back to Browser Hacking. Today we are going to work on a browser game in Ladybird, specifically the Cookie Clicker game. If you are not familiar, Cookie Clicker is an idle game where you bake cookies and you bake them by clicking on the cookie. It's that simple. Every time you click, you get a cookie. And the more cookies you get, you can actually spend them on upgrades over here. Like I can purchase a cursor, which then spawns this little hand here that spins around the cookie and clicks it once every 10 seconds. And it's sort of, you buy upgrades to automate the process of baking cookies. And something I particularly like in this game is that there is a silly upgrade called a grandma, which lets you buy a grandma who will then bake cookies for you at a rate of 1 cookie per second, I think. Yep. And this game does not really work in Ladybird. It displays, but you can't actually bake any cookies. But it looks like it's close to working, right? So the goal today is going to be to try to bake a cookie, I guess. And maybe if we could even get it to the point where we can purchase a grandma, that will be fantastic. So that is what we're going to try to do today. All right. So the first thing we need to figure out is, why does clicking a cookie not achieve anything? And in order to understand that, we got to start with looking at what actually happens when you click on a cookie. So we can see in Firefox that there's a button here called Big Cookie, and it has an event handler for, it has a bunch of them. So click, mouse down, mouse out, and so on. So presumably when you click on the cookie or when you mouse down on the cookie, I would guess that maybe it's on mouse up. Big cookie state changes. Yeah, so somewhere here in one of these handlers, some logic should run. And I'm guessing that we're just not running the event handler for whatever reason. So let's see. Why would we not be doing that? I guess one easy way we can debug this is by just printing out whatever you're clicking on. We can just print out in the mouse down event handler. So we'll go to the event handler class in libweb page, which is where all of the mouse down events from the UI process, they all come in here. And we look for whatever is under the cursor at the time when you're clicking a button down on the mouse. So let's see. Where do we do that? Here. If it's the primary mouse button, which is my left, then we do a hit test to figure out what's under the cursor. And where do we actually... Wait. No, that's too late. That's the text cursor positioning stuff. Where's the mouse event? Here's the mouse event being dispatched. Okay. So it happened earlier. Oh, here, this hit test right here. Okay. So earlier we do a hit test, which just traverses the paint tree to figure out what you're clicking on. And we see if we find something. If we do, then we try to convert it to a DOM node. And if we hit a DOM node, we set that as the currently hovered node, which updates like CSS hover styles and stuff like that. And blah, blah, blah. Eventually we dispatch a mouse event. So I guess here we could just debug like dispatch, or let's just say mouse down at hit and we will say print out the position and the node that you have hit. and maybe this will be educational. All right, so now if I click around on the page, it actually, you can see it prints out the coordinates where I'm clicking and also which DOM node I'm clicking. We have like this little pretty printer for DOM nodes. So clicking center area, background left canvas. Okay, so when I'm clicking on the cookie, I'm just hitting something called background left canvas. And then I'm just instinctively closing these notification things here. Yeah, so, oops. It seems like we're just hitting something called background left canvas. Now, the developer tools in our browser are not super great yet, so we're just gonna borrow the ones from Firefox and inspect the page. And we'll look for the background left. No, is that not how you do that? Background canvas, background left canvas is right here. All right, so this is what I'm hitting, which is a picture of the cookie. All right, and I should be hitting this thing, big cookie. So it has a Z index of 10,000, and the background left canvas has a Z index of 5. So, wait, doesn't that mean that I should be hitting the big cookie? Okay, I'm gonna go ahead and reduce this page so that I don't have to deal with everything in it. Maybe we can make a simplified version of it. So let's reset everything here, reload the page, and use the save page extension I have in Firefox, save page, to create a local copy of the page. And let's see. Okay, and then let's see that we can load that as well, actually. And Ladybird, does it load? Yes, it does. Okay. Oh my goodness, these are some very slow. Okay, well, I'm still hitting the background left canvas. So that's positive. That means that we probably have some kind of a reproduction here. Okay, and then we will use the Firefox DevTools to simplify the page. And like, let's try to just get rid of everything other than the cookie and the background left canvas thing. Let's see. Oh, okay, that was too much. I don't want to delete anything that changes the look of the page too much. Okay. Firefox is pretty laggy when you do stuff like this. But, oops. But the tools are pretty good though. Okay, so that's our background left canvas, and we're gonna see. Where's that big cookie thing anyway? Here. Okay, so we'll delete. Try to delete that. Okay. Get rid of the top bar thing. And I bet we have a bunch of stuff in the head element that we don't care about. Okay. Oh, that was too much. Okay, now we screwed up the layout, so undo. Okay. Detect ad blockers. Oh, you sneaky sneakers. Okay, well, let's hope that this isn't a problem with the detect ad blockers thing. Okay, and that one we had to keep. All right. Background canvas. Wonder if we can nuke that. Let's see, we still have the background left canvas here, and we have the big cookie. All right, so small cookie. Let's save that and see if, yes, we are still hitting the background left canvas and clicking on the cookie. And here, I don't have this debug output in Firefox, obviously, but by right-clicking on the cookie and choosing Inspect Element, I do get to the big cookie in the inspector here. So it seems like we're doing something wrong. So we managed to reduce this pretty well. Let's see what we can do further. So let's see. First thing, well, let's see what the HTML looks like actually. It's a little bit messy. So run prettier on it just to clean it up. See that it still loads and doesn't work right. That's good. And we have 3,300 lines of stuff. Cool. Most of it, almost all of it is CSS, okay. But we do have some stuff down here. Okay, so I'm gonna turn off wrapping in Vim just to make it bearable. And then let's see what we can nuke here. So let's nuke all the background properties and reload, verify that it still works. Also, this would have been maybe even nicer to have on mouse down actually, because then I don't need to click to get the output. Or mouse move rather, mouse move event. So where is mouse move? Here we dispatch mouse move. So let's just print when we do that. All right, this is really neat. Okay, so let's see. Now we need to reduce this further. So let's try to get rid of some wrapper diffs. So if I delete the outermost wrapper, reload the page, still busted. Delete another wrapper, still busted, that's good. Delete this one, still busted. Oh, that's very, very good. So that's becoming more and more simplified here. So now we just have the canvas with the Z index and a background. And it might be that we don't even need the background. Probably we don't need the background actually. Although it's easier to see when you have the background where the where the cookie is. Yeah, okay. So now we have these 3,000 lines of CSS. But we don't have a lot of selectors to worry about. Also, do we need the cookie anchor thing? Background left canvas, and let me just see over here. If I click on that thing. Oh, now button is up here. Oh, shoot. Okay, so I do need that cookie anchor thing. Cookie anchor, big cookie. Wait, what? Oh, big cookie is over here? Is that in the center of the page? Oh, I see. Yeah, I mean, that's probably just an artifact of me removing all the containers and stuff. Okay, so actually, let's just sketch out our own style sheet for this stuff. So we'll start with a universal selector and just slap a border on everything. This is the printf debugging of CSS, as I like to think of it. Background color, let's say transparent, also important. Boom. All right, there's a circle. That's the big cookie. All right, all right. So now it's actually working here, but not over here. Oh, shoot. Did I break this thing? So big cookie. Oh. Oh, wait, okay. So if these line up, then I'm hovering the canvas. So this is like where it's supposed to be. But if it's out here, the canvas, I guess the canvas only extends to here. So then you're hitting the cookie. And yeah, when you go here, you can see that this part is the cookie, but this part is the canvas. So it's like the circle is behind the canvas, essentially, or the big cookie div. So then we can definitely get rid of the image, because now it's just confusing us. Okay. And maybe we can even give these fellas some color, although let's get rid of all the other CSS. So we need background left canvas. Hopefully there are not a lot of, there's only one rule for background left canvas, that we can just copy that down here. And we also need cookie anchor. Also only one rule, very nice. And big cookie. There. Okay, Elder Wrath big cookie. I feel like that's some game mode that we're not in, maybe. So wait, how much is this? 16 lines or whatever. Okay. And then maybe we can just nuke everything else. So everything from line 4 to here. Boom. Oh wait, shoot. Not quite right. Wrong style element here. Okay, there we go. Reload, and do we still have the bug? Yes, I guess we do. Okay. So, still too much CSS, of course, so let's try to reduce it a bit further. Background canvas, we don't have that anymore. And this is a comment. Let's get rid of that. Background, not necessary. Border radius, let's get rid of that. Border, overflow, outline, cursor. Okay, well, now we got rid of the fancy shape, but the problem is still here, so that's fine. And then let's give these fellas some color. So I'm going to use my favorite debugging colors, orange and pink. And we'll get rid of that override. Boom. Okay, so the orange is our cookie and pink is our canvas. And I bet you if we load the same thing in Firefox, yeah, we'll see that the cookie is on top of the canvas. The orange is on top of the pink, and we are doing that incorrectly. Cool. This is progress. So now we have a demonstrable bug. All right. So I guess maybe we don't even need the border thing here anymore, although I'm more comfortable with the border on, I guess. The cookie anchor thing, do we need that? Or what if we just get rid of the cookie anchor? Then what happens? Now the cookie's always up here, but now it's also here. Okay. So the cookie anchor was position absolute. So the positioning of the cookie is a little bit awkward. Background left canvas. So I'm going to yoink this information from the background left canvas, just move it further up. So it's in the CSS instead. Just cleaning up the test. Just cleaning up the test a little bit. Here we go. Still has the problem. Good. And let's see, these coordinates are kind of awkward. So like, let's just say it's 200 by 200. And the cookie anchor is 200 out from the top and the left. So now we have a static layout instead of one that uses percentages. So it's a little easier to reason about, especially if we start looking at numbers. It's easier if they don't change just because I changed the window size, right? Okay, so what is going on here? We have a Z index on the canvas thing. Maybe we'll just rename that to canvas. And then we have a Z index on the big cookie. So I guess we'll call the big cookie, I'll just call it cookie. And this one we'll call anchor. All right. Streamlining a little bit here. All right. And then I'm gonna do another prettier just to tidy it up. Okay. Oh, shoot. I didn't call this anchor correctly. There we go. Cool. All right, well, that was exciting. Now let's figure out what's actually wrong. So I would expect the Z index 10,000 to put this thing above the pink thing. But why does that not happen? So what if I, why is the anchor thing necessary, by the way? So if I don't have the anchor, it doesn't happen. It's only if the anchor is present. So how do we debug this? Well, the first thing we need to look at is paint order, I guess, because since we're not painting things in the right order, we're not gonna hit test in the right order either. And the way that painting works in libweb is that we paint these things called stacking contexts. So it's a CSS concept, and essentially web pages are rendered back to front this is virtual layers, or in a stack of virtual layers called stacking contexts, I guess. And there are these rules for which elements form a stacking context or establish a stacking context. I forget what the verb is, but we implement this as a stacking context tree. Also, these mouse move messages are now getting a little bit distracting. So let's try that one more time like this. Dump the stacking context tree. Yeah, so we can see that we have a pretty simple stacking context tree here. We have a stacking context for the initial containing block, which is sort of the root level layout node, which always forms a stacking context. And then we have one for the anchor div, and we have one for the cookie div, and also one for the canvas div. So everybody gets a stacking context in this document, actually. And the stacking contexts are rendered recursively. So you start at the root, and this is sort of how all web content is rendered in our engine. We do everything based on the stacking context tree, and each stacking context sort of corresponds to a layout node, but there's not a one-to-one mapping. Like every layout node does not have a stacking context tree node or stacking context. As you can see, we have a lot more layout tree nodes than we have stacking contexts, and only some of them get based on the rules. So we could probably make an even nicer visualization where you would also see like all of the layout nodes inside of the stacking context. But either way, the important thing to know about stacking context is the size of it, which you can see here, and also whether it has children, and finally the z-index, because the z-index, that's the CSS z-index property. It determines the order in which sibling stacking contexts are painted. And let's see here. So we have z-index auto for the root, sure. And then the anchor has auto as well. And then the cookie has z-index 10,000, and finally the canvas z-index 5. So the properties are, at least the correct z-index properties from the CSS are showing up in our stacking context tree. But as I was saying, like the z-index determines the order in which siblings are painted, and the anchor here, which is a sibling of the canvas, and then the cookie is a child of the anchor. So the cookie is not a sibling context to the canvas. The anchor is a sibling of the canvas, which means that recursively speaking, we will first render document, and then we will render anchor followed by canvas, right? So that means that the canvas will be rendered on top of the anchor. And then the cookie is just a child of anchor, so will be rendered inside of the anchor context. So yeah, so it's kind of, you can see here why the canvas gets rendered last. It's because the z-index 5 means that it goes at the end of the render list or whatever. So something is wrong, clearly, because Firefox does not interpret it the same way, and it's probably going to be related to how we set up these stacking contexts in the first place. So maybe the anchor is getting its own stacking context and it shouldn't. That would kind of explain it, because then if anchor didn't get a stacking context, but cookie and canvas did, then they would be siblings underneath the initial containing block parent context, and then by ordering on the z-index, we would do the canvas first, followed by the cookie. So if we were incorrectly making anchor a stacking context, then fixing that would, I think, just make the problem go away. But why is cookie becoming, or why is anchor becoming a stacking context in the first place then? So anchor is very simple. So it's just position absolute with the left and top. So we can look at, what's it called? Creates stacking context, form establishes stacking context. Yes, that's the one I'm thinking of. So this function returns a bool for whether a given layout node should establish its own stacking context. So let's see. So here are the rules that we implement for that. So if the node doesn't have its own style, this essentially means that it's just dumb text. It's not an element, but like a DOM text. And DOM text doesn't have style, and it can never create a stacking context, so that's always false. For the root, for the document root node, we always make a stacking context. So I think that's the initial containing block stacking context will always happen because of this rule. And then we get the computed value for position. And then if it's absolute, relative, fixed, or sticky, we return true. And we are indeed position absolute. So we will return true actually in all of these cases. So everybody gets the stacking context because of position absolute. Okay, so maybe I messed up the rules here then. So stacking context, I bet I did. Just, let's see. So something that's a bit annoying about stacking context is that there isn't like one place in the CSS specifications that is sort of the authority on what makes a stacking context. Instead, it's spread out across many different specs. And I haven't seen any of them make like a very, very clear indication of like, these are the rules. But I know that MDN, this Mozilla Developer Network thing, they have a pretty good summary here of the situations. So I like to look at this. And we are sort of implementing the rules here that they have. So a stacking context is formed anywhere in the document by any element in the following scenarios. Root element of the document. That's us. Root element. Element with a position value absolute or relative and z-index value other than auto. Okay, well, that's not entirely the rule that we implemented. What we have done is say absolute, relative, fixed, or sticky, then true. What it should actually say is position either absolute or relative, and then a z-index other than auto. And then for fixed and sticky, sticky for mobile browsers, not older desktop. Okay, well, we're a newer desktop, so sticky for us too. So for element with a position value fixed or sticky, we should just return true. And then other rules to follow. So I think, okay, so let's fix up this rule here, first of all. If position is absolute or relative, and then we'll break out the fixed and sticky to its own thing. And then it also had to have z-index other than auto. So if computed values, z-index, if it has a value. So z-index we store as an optional. So an optional int. So if the optional is empty, that means that it's auto. And if it's an integer, it means that it's some integer number, basically. Zoo, if we have a value, that means that we're not auto, which means that we should make a stacking context. Cool. So what happens if we do this? Hey, look at that. Okay, so now the cookie is on top of the thing, right? And just to verify, yes, I can hit it right here. And let's go to the cookie clicker thing. Cookie clicker. Hey, look, I'm over the cookie. And I can click it. I'm making cookies. Although the page doesn't look quite right. So it seemed to have broken the rest of the page quite a bit because I'm missing the background and images everywhere and stuff. So that's not very good. Also, I was supposed to be able to buy upgrades, but I'm not seeing that either. Okay, well, so clearly by taking away the stacking context for everybody who is position absolute or position relative, and only giving them to those that have a non-auto z-index, we've clearly upset the web by not rendering it correctly. So probably we rely on the incorrect creation of stacking context. So hold on, I just want to see if we dump the tree now. Yeah, we can see now that we don't create it unless you have a non-auto z-index, then the canvas and cookie elements become children or become siblings under the initial containing block, and that's why they get ordered by z-index and everything comes out correct. So that part is good. The part that's not good is that we're not rendering correctly. So it'd be nice if there was a simple page that broke, so I didn't have to debug the huge cookie clicker page? Like, what if like the acid tests would break or something? Because I already know those. Okay, well, this definitely broke acid 2 very hard, so that's good, because this we can debug semi-easily. So let's see. What would have happened here? So I know the acid 2 test is, it's a very big stress test for paint order and the z-index property. Like they have a lot of shenanigans going on, testing that things paint in the correct order, because before we fixed up our paint order, we were quite bad on acid 2. So CSS paint order. Oh, that's a property these days. That's not what I meant. CSS paint, let's just look up z-index. Z-index. And where's le spec? Take me to the spec. Okay, specifying the stack level. Right, so here is essentially the paint order. It's a high-level description of the paint order. So it says, within each stacking context, the following layers are painted in back to front order. So not only do the stacking contexts themselves act as layers, but there are also sort of virtual sublayers inside of stacking contexts, where you paint a stacking context in 7 separate phases. So you do backgrounds and borders, and then you do child context, and then you do inflow, non-inline level, non-position descendants, and so on. And all of this very elaborate rules have to be followed, or it's not going to look right. So how have we upset the order of things so badly that we don't paint anything? Well, what is the thing that we're not painting here? I guess, or rather, what is the thing that we've changed? We've changed so that it used to be that everything with position absolute would become a stacking context. And now only non-auto z-index will. So previously, there would be a bunch of child stacking context, with negative levels. So not those. So I think auto is treated effectively as z-index 0 for the purpose of paint order. Yeah, so let's see, child stacking context with stack level 0, and the positioned descendants with stack level 0. Okay, so I know there's a more detailed description here in Appendix E. Elaborate description of stacking contexts. This is where we want to be. All right, so this is where it gets real nitty and real gritty, real fast. So this is the actual paint order of CSS. It's very elaborate. Okay, all position descendants with z-index auto or z-index 0 in tree order. So we're definitely position descendants because they're all position absolute. So they are positioned. They have either z-index auto, but they don't have z-index 0. But okay. But we do have one that's z-index auto. That's this guy right here. This is effectively z-index auto. Because that's the initial value of that property. So let's see. Let's just organizing these so I can see. Okay, so what does that mean? So z-index auto. So I guess previously we would do the anchor here in this part, because it's z-index auto. No, I don't know. This is too messy. I can't figure it out just from staring at the text. So I'm gonna take acid 2 and reduce it a little bit. So let's see, acid 2, acid test, arg. Okay, and let's see. Oh, actually, I have a local copy of it. We have it in the Serenity sources. And let's just edit that a little bit. So I know there's a huge top margin thing here. Yeah, this guy. Just take that down to 2 EM or 1 EM or whatever. And then open it up. Okay, yeah, so we don't have to deal with that scroll offset thing. And let's see if we can also get rid of all the gunk up top. The standards compliant div. Okay, here we go. And if I open this in Ladybird, I just see this. Great. So now let's just reduce. Still only that. It's a little too far. Okay, so this thing right here. Okay, this is a very good. It's getting very simplified. So we have first 1, second 2 that we want to hang on to, and then I think we can like delete all the other gunk here. I've reduced this test so many times that it's just it's pretty easy to take out everything except what you need. So we don't need the intro. Hey, I went too far. Okay, dang it. Shoot, when did I go? Oh, maybe I remove the end tag for the style sheet. Yeah, that was goofy. Okay, don't mind me just doing a little bit of routine cleanup here. Okay, you out. Can we get rid of you too? Yes, we could. Great. Cool. And do we need you guys? Okay, and then simplify the selectors. 1 and 2, and still looks good and bad. Great. Use prettier, clean up the look so we can see everything. Nuke the gunk. And I can barely see the yellow here. Let's make it red. Okay, so still nothing showing up here. That's very good. Okay, just that final bit of cleanup. So what is going on here? These, do we need the picture wrapper? Maybe we don't. Nope, we didn't. Maybe these don't need to be block quote and address, but just plain div is fine. They can just be 1 and 2. Good. Margin and padding, don't need you. Okay. Don't need to be float. All right. So what on earth is going on here? Now we just have 1, which is the outer, and 2, which is the inner div. 1 is position absolute. 2 is nothing special. And our stacking context tree looks like what? Like this. We just have a stacking context for the initial containing block. So this guy doesn't render at all. The inner div does not get rendered. That is not correct, clearly. So we used to believe that 1 should have a stacking context because it was position absolute, but now since it only has the initial z-index of auto, it does not get a stacking context, which means evidently that we don't paint it. Also, let me just, let me just flesh these out a little bit here, just so it's more visible. There we go. Okay, so why don't we paint you? What if this thing had some color? Do we paint this at least? Background cyan or something? We don't paint that either. All right. So this is information. Okay, so when do we normally paint these then? So let's go back to the CSS rules for this stuff. What were they saying about this? They were saying that in the great big description of paint order, here in phase 8 or whatever, all position descendants with z-index auto or z-index 0. So it is a position descendant with z-index auto. So it should be painted at step 8 here. For those with z-index auto, treat the element as if it created a new stacking context, but any position descendants and descendants which actually create a new stacking context should be considered part of the parent stacking context, not this new one. I'm not sure what that means. For those with z-index 0, treat the stacking context generated atomically. Okay, well that's, I didn't quite parse that, but maybe we can ignore that. That sounded a bit like convoluted, so let's just focus on the first part. All position descendants with z-index auto or z-index 0. So we are screwing that up in stacking context paint something, paint, I think it's paint. Stacking context paint. So we paint into a paint context. A paint internal is what I'm looking for. Right. For a more elaborate description of the algorithm, see CSS 2.1 Appendix E, which is, that's what we were looking at. Appendix E, this thing right here, elaborate description. Right. So let's see. So these steps here are essentially implementing this list of paint phases. So this is step 8, all position descendants with z-index auto. We should be in here. Steps 8 and 9, position descendants. For auto child and children. Aha! Okay, I see. So it's obvious that what we do here to implement this step is that we just iterate the children, which is the list of child stacking contexts. And that obviously worked before because we would create a stacking context for everything that was position absolute. So So this was sufficient. Like you could just paint all the child context and you would cover all of the positioned children. But now that we don't make stacking context for everybody who's positioned, this is too simple. So what do we need to do then? We need to actually paint position descendants. So then it suddenly becomes a lot more complicated. All position descendants in tree order. Dang. So I guess we need to traverse the tree here, basically. Oh, this is steps 8 and 9. Step 9 is stacking context formed by position descendants with Z index greater than or equal to 1. Okay, so I think step 9 will be this stuff. Because this is fine for step 9, because if everybody has a Z index greater than or equal to 1, then they're not autos. So they will have stacking context. So we can just iterate. Let's see. So what does this code do? So if we have a Z index that's non-auto and it's less than 0, then continue. So I think the logic here needs to be if you have one and it's greater than or equal to 1, then we should paint. That now it becomes step 9. But for step 8, draw positioned descendants with Z index 0 or auto. In tree order. Step 8. Okay, so that would be something like starting from the box. Yeah, so the box is going to be our layout box. We'll just start there, I guess. So mbox paint box for each in subtree of type. So for all of the paintable boxes in our subtree, what are we going to do with you? We are going to, they said that if you have Z index 0, we should treat the stacking context atomically. So let's see if paintbox, so paintbox is a descendant and we want to only look at position descendants at this point. So is positioned. So if it's not positioned, we continue. But if it is positioned, then we care about the Z index. Okay, so we get the Z index. Paint box, computed values, Z index. Okay. So if we have a value and Z index is not 0, then continue. Return traversal decision, continue. Right, because it has to be either 0 or auto. So it has to either not have a value or have a 0 value. Okay, so now we're here, and we know that we are looking at a position descendant with a Z index of 0 or auto. So let's see if it has its own stacking context. If paint box stacking context, then if so, paint box stacking context, or no, paint child stacking context. Let's see, child stacking, child context. You could do something like that. Or just child even. And then if we paint the child context, we don't have to traverse into it. So that's a skip children and continue type situation. Okay, and then we're looking at something with z-index auto then. So something that doesn't have its own stacking context, but we still have to paint it. So at this point, paint box is a positioned descendant with z-index auto. But no stacking context of its own. And we have to paint that. So we're just going to paint a normal, as if it's a normal box, which means that we, suddenly factoring is a little awkward here because because we have to do this, like first do these phases, and then we got to do these phases. I think it's like first we do the background and the border of the position descendant itself. And then we do all the descendants of the position descendants. So do their backgrounds, their floating descendant, and so on. This feels very messy-ish, but let's see. Not quite enough to solve our problem. Let's see, I had the... Wait, where was this file? Oh, in downloads. Okay, not good enough. Sure. So let's see. How did I mess this up? For each and subtree of type. Visit, let's just print out what we're visiting here. So mbox, or no, paint box. Oh wait, hold on. I'm using mbox everywhere here. And these, and this lambda. Paint child. I want to use not mbox, but paint box layout box. I have a const and I can't pass that to paint descendants. Why are you mutable? Don't be mutable. Painting the layout tree does not mutate the layout tree. Should not mutate the layout tree. So that should be fine to just rebuild. I don't think anybody uses any mutable functionality there. Yeah. Okay. Good. So does that solve all of Facet 2? Yeah, it does. Okay, so this is the remaining breakage is breakage we still have on Asset 2, haven't fixed yet. And cookie page, what's the cookie clicker? It's a complicated URL. Why aren't they cookieclicker.com? Okay. So, hey, this is looking way better. Cool. Okay, so actually I'm missing text here, so it's not perfect yet. But, ooh, look at that. But, I'm not getting any cursor. And why not? Actually, it doesn't print anything when I hover over the cursor. That's suspicious. Also, why don't I get text here? That's also suspicious. Maybe I forgot something. So the way that we do the z-index auto paint is pretty right. We forgot about these three phases here. Focus, outline, and overlay. Although I just don't feel like they should. We forgot about these phases, but they shouldn't be what creates the missing text, or I don't know. I shouldn't guess. Let's just try it. No, it still doesn't show up. Dang it. So what is this text down here? This text is missing. Okay, so it has opacity. That's suspicious. So it's an H5 inside of a note 1, text H5, blah, blah, blah. All right, so let's take a look at the stacking context tree here in our browser. Why is nothing coming out? Oh, here it is. Oh, look at all these stacking contexts. Notes. Okay, so we have notes. We have the H5 inside of notes, which is a stacking context, I would assume, because it has opacity, and any opacity other than 1 should create a stacking context. And then the close button is there. Oh. I thought we were doing something wrong. Like there's this weird flicker, goes to black and then comes back in color. Firefox has that too, although it's faster, but like still does it. All right. Well, wonder what's causing this. I wonder. But maybe we can ignore that for the moment, since everything else is kind of cool, and see what this is. So why can't I click on that thing? Let's see. So it doesn't, I'm not mousing over anything. That is very suspicious. So mouse move, handle mouse move. Why are we not printing anything? Handle mouse move. We already added the debug line to print out the mouse moves. Evidently, we're not making it this far. I guess we can look in Firefox. So what is this thing even? Why can't I hit it? Div ID product. Div product 1. Okay. Says 300 by 64 surface content box. Got a little hand. Got a bunch of different things here. There's an after pseudo element covering the whole thing. I guess it's this thing right here. I wonder if that's screwing everything up, because z index 100. Interesting. So that's funny. There's actually a PR in the PR queue where Gunnar is fixing an issue with hit testing on pseudo elements. Here, pick the correct DOM node for mouse events on pseudo elements. And I gave some suggestions for how the patch could be better. And Gunnar didn't get around to implementing those suggestions yet. So let's take a wild guess that it's going to be the same. I guess he was debugging knitter.net. So let's take a wild guess and see if it's the same exact problem. If so, then it should be a matter of, let's see. So basically what happens is, what happened in his case was that you hit a pseudo element, and then we want to find a corresponding DOM element to actually dispatch an event on, because pseudo elements don't have a corresponding DOM element. They are sort of inserted virtually inside of an existing DOM element, but they don't have an entry in the DOM of their own. In fact, what you see here in the Firefox DevTools, like this little : after, this isn't part of the DOM proper. It's just inserted here by the DevTools to help you see where pseudo elements are instantiated. We hit test our paintable tree. So, and there's always a paintable for pseudo elements, and there's always a layout node. There's just no DOM node. So, so here, this is mouse move, right? Yeah, handle mouse move. So we've hit some paintable, and then we ask the paintable, do you have a preferred mouse event target? If no, then we just ask for the DOM node. And then what I suggested was that if you couldn't get a DOM node directly, then if you still have no node after this, then you could say something like, well, if there's no DOM node, but the paintable layout node has a parent, then paintable layout node, parent, DOM node. So just get the parent DOM node, essentially. Because paintables can't tell you their parent. So it's a little awkward, and we could bundle it into a helper, but let's just see if that fix actually works. Because if so, that is kind of funny that oh, look at that, they're lighting up. Okay, very promising. Okay. This text is still missing here. It's a little annoying, but can I buy a cursor? Oh, right. I only did mouse move. So it's not gonna react to mouse down. Okay, so let's see. So let's make a helper here. So like node is gonna be DOM node for event dispatch, and then we'll pass in the paintable. Yes, and then we'll do this, and we'll say static gc putter to DOM node for event dispatch, something like this. And then okay. And then I guess we can do something like if return node, if auto node is a return node A. Yeah, so something like that. Okay. And then, DOM node for event dispatch, right. And then we just look for node equals paintable mouse event target. And we replace that with node is DOM node for event dispatch. Then I guess this needs to be a bit further up in the fillet. Don't mind me, just moving to the top. Very good. Okay. All right, we're making cookies. Just need 15 to buy a cursor. Oh, look at that, got a cursor. Look at it go. Is it actually clicking every 10 seconds? Will I get a third cookie? Come on, little fella. It did eventually click. We got a third cookie. That's so cool. The Canva's rotated painting implementation, you can see it's kind of a little bit crappy here. You can see it is not rotating in a very smooth way, but it is roughly approximately what it should be. So I guess I gotta help it a little bit. It's not as fast as it is in Firefox, I think, as probably they're running a ton of JavaScript and stuff. Or rather, they're doing a ton of, you can see there's a ton of canvas painting going on here, which we are definitely not very fast at, especially if you're rendering anything in Canvas through a 2D transform, which I think they are with a rotate here. We're definitely super slow at that. So we need to improve that so the cookie clicker can feel faster, obviously. I just want to get to 100 cookies so I can buy a grandma. And come on, give me the grandma. Yes. Oh, look at that. I got a grandma. What did it say? These are stacking on top of each other a little bit awkwardly here, but it says, come give grandma a kiss. Cool. All right. So we got to the point where I could buy a grandma. That is fantastic. Dreams do come true on this YouTube channel. So I guess first thing we should do now is some commits, and I'm expecting this at 100% CPU. Yeah, very much. Yeah, so it's a good target for optimizations. And I don't like that the text of the little messages that are popping up is not displaying, but I feel like that's something that we can separate out from everything else. So let's see. Let's start with the event handler, I guess. And oh, I had a debug line in here somewhere that I wanted to get rid of. Yes, that one. The DOM node for event dispatch. libweb. Dispatch DOM mouse events on parent. Try harder to find a suitable DOM node for UI event dispatch or mouse event. Our hit testing mechanism gives you, since our hit testing mechanism gives you a paintable gives you the paintable under the mouse cursor. We can't just give up if that paintable doesn't have a corresponding DOM node. That means that generated content like pseudo elements don't get mouse. Don't generate mouse events at all. That meant that. That meant that they didn't. All right, we're getting there. Fix this by making a little helper function that was called DOM node for event dispatch. Yeah. That finds a suitable DOM node when given a paintable. There's probably this first cut is very naive, and there's probably more we should do, but we have to start somewhere. All right. And then let's do the updating the rules for the stacking context. So I guess let's copy the text that they had to describe it here. Yeah, just to be good boys, you know, reference the reference material, and let's even add a link to this. Note, while MDN is not authoritative, there isn't a single convenient location in the CSS specs specifications where the rules for stacking context is described. That's why the spec link here points to MDN. Yeah, I just maybe that goes above here or inside. Anyway, I just wanted to make a note of that so that other people can be aware of how it's not authoritative, but nevertheless very helpful. Okay. So what do we say here? Don't create stacking context for, or let's see, fix bogus stacking context creation. No, don't create stacking context for all positioned elements. I had mistakenly, or we were mistakenly creating stacking context for all elements with non-static CSS position when for absolute and relative, we should only create stacking context if the z index value is something other than auto. This makes it possible to click the cookie on cookie clicker. All right. And then we gotta fix the painting thing. Right, and then I had that, I made a function parameter const, so let's just separate that out first of all. What was that function parameter? It was paint descendants. Don't take mutable or stacking context paint descendants. Can take const layout node. It doesn't mutate the layout tree in any way. Yes, and then this part. Oh man, I don't feel super great about this part because it feels really clunky. And also I think I sort of purposely ignored a bunch of the text here just to just to make progress, but like yeah, there was a second part that I don't even understand yet. I need to sit down and understand what this means so that we can implement it fully, but for those with z-index auto, treat the element as if it created a new stacking context, but any position descendants and descendants which actually created new stacking context should be considered part of the parent stacking context, not the new one. Yeah, I'm sure that means something subtle but important. So maybe what we should do here is fix me. There's more to this step that we have yet to implement. That we have yet to understand and implement. Let's make a note of that. Okay, so let's see. This is basically duplicating the logic from outside this function. This is duplicating the logic elsewhere in this same function. Find a way to share code, or find a way to make this more elegant. Yeah. Let's just jam that together. So yeah, so here we have like just jam together all of the steps outside. So if the paint box had a stacking context, then we just paint the stacking context and then skip. Yeah, so it ends up in tree order because we're just traversing the tree rather than traversing the list of child contexts, which means that we will paint these in tree order, but that's correct. And they have to be positioned. This seems vaguely correct-ish. So this is probably okay. Probably good enough. Let's I don't know. Let's go to some other websites just to do a quick smoke test. Is Linus's website coming together? Oh, well, that didn't go well. Wait, GitHub doesn't work? That's concerning. So we have a problem when we're painting. Ah. Wait, why doesn't GDB attach? I have follow fork mode child. Should be attached to the child. Okay. Yeah, that happens sometimes. People were complaining about it on Discord as well. I have to actually figure out what's going wrong with that. But like sometimes GDB just doesn't attach to the child properly, and then the web content rendering process just crashes. And track children, trace children. This is sort of my backup solution, which is if something is crashing in the web content process, I can always just launch it in Valgrind. And at least that allows me to see a backtrace. Although it takes a long time sometimes. Okay, here's our crash, and we are in Paintable Box Paint. Paintable Box line 171. Say what? Painter restore. Painter restore, okay. Which does it verify that? So there has to be something that we're restoring. So we didn't save before. So we're trying to do a restore when we didn't save before. But why is there a standalone restore here? For the clip property. So it's corresponding to this fella up here. Oof, this looks really goofy. So like, as I was saying earlier, like we paint everything in phases. So background phase comes early, and then overlay phase comes later. So we save the painter state when we're in the background phase, and then later on in the overlay phase, we restore the painter. So I guess we apply the clip, and we want the clip to apply in all the different phases between background and overlay. So background, so we want the clip in background, border, foreground, and focus outline, but not in the overlay phase. There's a really weird way of doing that, but why would it break now? Oh, am I not calling all the phases? So I would break this somehow? How would I break it? If I would call overlay without having called background, I guess. How would that happen? So let's see. So we do background on the, so I think it's going to be here somewhere in this thing that I already feel awkward about. So we do background and border of the z-index auto position descendant right here. So now we have a clip potentially set up on that guy. And then we do all the descendants. So we do descendants, background, and borders. What does paint descendants do though? Paint descendants. If child establishes its own stacking context, skip over it. Okay. Background and borders. So we don't paint background and borders if it's positioned. But I bet we do the overlay even if it's not positioned. Okay, so let's see. So previously, anything that was positioned would have its stacking context. So you would early out here because position meant it had a stacking context, so you wouldn't progress. But now, if you're painting something positioned, we skip over the background and borders. But we don't skip over overlay. And when we get to overlay, we try to restore any clip, and then that breaks. Why do we refuse to paint position, background, and border? Does that make sense in the first place? I don't think this check was ever validated, or like, because positioned, you wouldn't have been here with a positioned element anyway, because it would have been skipped because it had a stacking context. So maybe this is just bogus. Like, you don't need these position checks. It's an optimistic attempt here. Interesting. So there are things that are not being clipped. Why are these things not clipped? What are they part of? Okay. How does cookie clicker look? That's important. Okay, so we didn't solve this issue. GitHub paints again, but it's a little bit weird. I mean, on one hand, like, we now have a more correct representation of stacking context, which is good. These drop downs here actually look more correct than they have before, which is great. They used to be transparent, now they're not, so that's progress. Although there's something, like, I mouse down here and it brings up the the pop-ups. This is definitely not the way it's supposed to be. Yeah, there's more to this stuff, but I think this is still progress. It's just stuff that we're gonna have to continue to improve upon. So I'm gonna go ahead and say, what do I say? Yeah, we're going to say that this is still progress, and there's more to be done for sure, but we have to be willing to eat a little breakage sometimes, because if we fix some, now we fixed an architectural problem, right? Like we were incorrectly creating stacking context, which our painting code was built around the bad assumption that everything positioned would have a stacking context. And we've probably stacked bugs on top of bugs, assuming that incorrectly. So now we have to suffer through the process of like figuring out what bogus behavior we've added on top of our engine to deal with this bad architecture. But I think that shouldn't stand in the way of this particular progression that we have here architecturally. So let's say, or no, now, dang it, now I conflated two separate things. Let me do that. And I wanted to have the paint descendants, that changed. Let's do that one separately. Update stacking context paint descendants for new architecture or new z-index rule. Since z-index or since new dang it, new rule, since positioned elements no longer automatically create stacking context, we can't rely on the assumption that can't rely on this assumption when painting descendants of a stacking context. This was found. This particular issue manifested, or this in this commit, we fix an issue that manifested as a failure to graphics painter restore in the overlay paint phase. What happened was that a CSS clip was being applied in the background paint phase and then unapplied in the overlay phase. Because due to bogus checks in paint descendants, the background phase never ran for positioned elements, but the overlay phase did. The check for, let's see, this actually belongs to this paragraph. Okay, the check for positioned elements was bogus in the first place and had never actually been true. Never actually worked before, since we would always early return early, always skip over positioned descendants due to them having stacking context. Now that they no longer do, we yeah, that's okay. Hopefully, if we have to understand this in the future, this comment will help us understand. Okay, and then what was remaining? It was the right, the step 8 and 9. Improve painting. Actually, paint positioned descendants with the index auto. Yeah, this worked before because all positioned elements would generate or would create their own stacking context, and we'd paint them. I don't know. When we stopped doing this, there was nobody to actually paint positioned descendants with the index auto. This patch adds splits up steps 8 and 9 of the paint order algorithm and implements step 8 as a tree, paint tree traversal. There's more to step 8 than I've implemented here, so I've left a fix me for our future selves. Yeah. Oh, all right. Yeah, this is definitely a little bit messy, but it still feel like it's good progress. So let's take it and let's continue iterating on it. But this is going to be the end of today's video. So I hope that you've seen something interesting here. Thank you so much for hanging out while I work through Cookie Clicker. I'm happy with the result. I think it's definitely exposed a bunch of, what is it, Ortile? Definitely exposed some new issues that we need to take care of. And probably there's more regressions that are gonna be found because of this, but on the whole, like better architecture means a better future for our engine. So let's do it. And yeah, we can now buy cursors and grandmas, and presumably you can just keep playing the game forever. But we will have to make it a little bit faster because it might not be too visible in the video, but it is irritatingly sluggish, I think. But this is Cookie Clicker. Thank you very much for checking out the video and for hanging out. I will see you all next time.